Have you ever stopped to wonder what light really is? It's around us every day, pervading every aspect of our lives. It illuminates our homes, paints our world with vibrant colors, and even powers the technology we can't seem to live without. Yet we rarely give it a second thought. But let's delve deeper. From a scientific perspective, light is far from ordinary. It is an extraordinary phenomenon that has puzzled and fascinated scientists for centuries. It's not merely a tool for visibility, but a complex entity with properties that boggle the mind and challenge our understanding of the physical world. In the grand theater of physics, light plays a starring role not just as a performer but as a perplexing paradox. The simplicity of light as we perceive it belies a deeper complexity. Yes, it's true, light, as simple as it seems, has a dual nature. It behaves both as a wave and a particle. Now, this might sound complicated, but imagine this. To simplify the wave nature of light, let's think about a quiet pond. You're standing at the edge, and you toss a stone into the calm water. What happens next? Ripples. They start from where the stone entered the water and they spread outwards in circular patterns. This is similar to how light behaves as a wave. Just like those ripples, light too radiates outwards from its source in all directions. It's an energy wave, spreading out, reaching places, and bouncing off objects. But here's where things get interesting. Light doesn't just act like a wave, it also behaves like a particle. This might seem a bit hard to grasp, but bear with me. Now let's shift our scenario a bit. Instead of a tranquil pond, imagine a man with a gun. He pulls the trigger, and out comes a stream of tiny particles, each rushing towards their target. That's a pretty close depiction of light behaving as particles. These light particles are known as photons. They're like tiny bundles of energy being fired out from the source of light. And just like bullets from a gun, these photons can hit and interact with objects in their path. So what's the deal here? Is light a well-behaved wave smoothly radiating outwards, or is it a stream of reckless particles darting around? The answer is, it's both. Depending on the circumstances, light can exhibit characteristics of both waves and particles. It's a bit like it can't make up its mind about what it wants to be. This is what physicists call the wave-particle duality. It's one of the most fascinating and admittedly puzzling aspects of quantum mechanics. It tells us that light, this everyday phenomenon we take for granted, is far more complex and intriguing than we ever imagined. So, it's like light has a split personality. Sometimes it's a wave, sometimes it's a particle. So here's what you should remember. The dual nature of light, or wave-particle duality, is a cornerstone of quantum mechanics. This principle tells us that light doesn't strictly adhere to our everyday notions of wave or particle. Instead, it exhibits characteristics of both, depending on the circumstances. When light is in motion, it behaves very much like a wave. It can diffract, interfere, and show all the other behaviors we associate with waves. Then, when light interacts with matter, it takes on the persona of a particle. It can be absorbed or emitted in discrete amounts called quanta, showing us its particle side. This quirky characteristic of light, being both wave and particle, isn't just an abstract concept in theoretical physics. It's a fundamental principle that has real-world implications, shaping our understanding of the universe at its most fundamental level. It's a strange and fascinating world at the quantum level, isn't it?